Can an ordinary person simulate a typhoon? Of course they can. Imagine a pot of boiling water. If you place blocks of dry ice on either side, the cold air released will continuously flow toward the hot water. This happens because the boiling water heats the air above it. As the air expands, its density decreases, causing it to rise. On the other hand, the air cooled by the dry ice becomes denser and sinks, staying close to the ground. As the warm air rises, it leaves empty space above. The cold air rushes in to fill the void. If you surround the boiling water with a ring of dry ice, the cold air will gather toward the center, and as it gets heated by the water, it will rise toward the center. But how do you make it spin? You quickly come up with an idea. You blow air from the side. Miraculously, the cold air moving toward the center shifts direction and starts to spin, creating a vortex that gets faster and faster. Congratulations, you've just discovered the basic principle behind a typhoon. Now, if you scale this entire setup up by thousands of times, the pot of boiling water becomes a vast, warm ocean surface in the summer. The surrounding cooler seas and air represent the cold source, much like the dry ice. When the sea surface temperature exceeds about 26.5 degrees Celsius, large amounts of water evaporate into steam, rising dramatically like the steam from a boiling kettle, reaching heights of over 10 kilometers. The surrounding air keeps pouring into the center, carrying moisture upwards to participate in the next cycle. As the temperature continues to rise, the system grows, potentially expanding to thousands of kilometers. Normally, these rising water vapors wouldn't pose any danger, but Earth's rotation causes the straight-moving air to veer off course, eventually forming a rotating cyclone. When the cyclone's wind speed exceeds 118 kilometers per hour, congratulations, you've got a typhoon.